Okay. Well, I'm here to talk about a project. Again, my name is Stead from KIOXIA, and our project is called Software-Enabled Flash. And it's been in development by the KIOXIA team for about 4 years, and it just became a Linux Foundation project earlier this year. And then we're also joining in with the SODA Foundation for the Eco project. So we'll hopefully we'll see everybody in London next year. I just put that on our agenda, so hopefully we'll be at SODACON London. Looking forward to that, and then we'll be a little bit more engaged on the SODA Foundation Eco. So Software-Enabled Flash again is a Linux Foundation project. It's open source, and it's a software-based capability to expand Flash beyond legacy hard drive protocols. So currently SSD in the hyperscale data centers, everything is still based on the legacy HDD protocol. So what we've done is we're bringing a new paradigm for flash memory. We're going to bring it into, expose the full capability of Flash. And the way we're doing that is with storage developers, we're going to bring the hardware from different vendors. So the hardware will be purpose-built for software-enabled Flash capability. And then the software layer, the API, is going to be distributed through Linux Foundation. And we just had our first technical steering committee meetings this year. And so what we're trying to do is really take advantage of the ability to control Flash. It's not just performance. We're not just going after just maximum performance. We're going after the maximum control of the Flash layer and the hardware. And again, this will be available from multiple Flash hardware vendors. And then everybody will have the ability on the software developer platform to control for their environment, whether they want consistent latency, whether they want highest performance, or whether they want to extract or abstract the Flash for the maximum control of the data. So again, this is an open source community project. We'll be launching early next year. You'll see more with the API and the SDK. And what this is going to create is a much faster time to market for new, higher density, presumably lower cost Flash hardware. And you'll be able to migrate on the data center, your applications, to the latest versions of Flash hardware. So again, this is underneath the Linux Foundation project. We're using the standard open source governance process. Again, we just had our first technical steering committee meetings this year, and then we'll be launching with the open source and SDK kit early next year, and it is available on GitHub now. Again, this is a combination of hardware. So on the left side is the PCI hardware. This is purpose-built, so it wouldn't be just any drive, but there's a purpose-built PCI flash-based hardware in the hyperscale and data centers. And then combined with the software from the Linux Foundation, that again, anybody can contribute and control and help advance on the platform to, again, really abstract and take advantage of Flash hardware. And so some of the things you can do to take advantage of the Flash hardware is die-level isolation, complete physical separation of data, and user configurable at deployment for the software. And this helps you control the quality of service domain, workload level isolation, and again, complete logical separation of the data at the superblock level. And then you can do a lot more things with garbage collection to help improve not only the data integrity, but also the life of the Flash device. So again, with the open source stack, combined with purpose-built hardware, the software-enabled Flash device driver allows applications at the data center level to incorporate new Flash media without having to modify the applications in the data center. So what we're delivering now at our GitHub site, we've got the full documentation and some sample code API. And again, this helps at the Flash translation layer, and we've got some virtualized device drivers, as well as the standard FIO testing tool capability, and then the command line interface as well. So what we're trying to do is, again, the faster deployment of new flash media, because as we know, the flash media changes every 18 months or so. So instead of having to rewrite applications on the server level, you can just, with software-enabled flash at the host level in the data center, you can incorporate new flash hardware very easily. So again, this creates agile opportunities for your applications to just incorporate the newest and latest hardware from different vendors. And KIOXIA developed the original software platform, but again, this will be available from multiple hardware vendors. So what we're looking for is engagement. There's two different things going on. There's the awareness level, which we appreciate with the SODA Foundation helping us get engaged at the awareness level. And then there's also the adoption level. The early adopters for this will be the hyperscale, the largest hyperscale data centers. And then so you'll start seeing more and more with flash-enabled, software-enabled flash next year. So again, this is a new project that's just being introduced. So if you haven't heard of it yet, you will hear about it more and more next year, again, as it gets deployed in the hyperscale data centers. So our website is very simple, softwareenabledflash.org. From that site, you can get on the mailing list, get more information, join our technical steering committee, contribute, or just learn and see all the documentation, as well as some sample API hardware. So again, the membership is an open source project. Everybody's welcome to take a look at everything that we're doing on the software side. And again, you'll start seeing more hardware from KIOXIA as well as other flash hardware vendors as we get into next calendar year. And please take a look at softwareenabledflash.org and enjoy the SODACON. And I appreciate the invitation to come here. And again, software-enabled flash, just to kind of reemphasize, is a open source software combined with purpose-built hardware from different manufacturers. And take advantage at the data center, or the largest data centers initially, but you'll start seeing it move into the middleware as well. And I think that's it. Okay, so I know if there are any questions, you can ask me now, or I'll be here all day. So. The API is a host. The host-based.
It's a very low level of storage.
Yeah.
So the POSIX-based API, do you support REST-based or SOAP-based? Which protocol do you support for that API?
I'm not sure.
Because I'm not very sure about that, whether this Flash supports REST and all those things.
Yeah, because it's purpose-built hardware, so it's, but I'm not too sure what, we probably have that answer on the site, or at least on our GitHub. I know it's in the GitHub documentation, but I don't want to guess.
Okay.
So,
so do you in your PPT, do you have the link of GitHub repo?
Not yet.
Not yet, okay.
Yeah.
Thank you.
Maybe, Yoshida-san, you have a... There we go. So this is my partner, Yoshida-san from KIOXIA, Japan.
I'm from KIOXIA, Japan, and doing the software-enabled flash. So currently, software-enabled flash has support for Kubernetes, and at that level, there are some REST level API. And besides, we are also doing NVMe over Fabric software. And at this level, REST level API is also supported. So software-enabled flash API is much lower. Yeah. And yeah, so this is somewhat different. Thank you.
Okay.
Thank you very much.
Thank you, Yoshida-san. Okay, good. It's always good to have some backup teams. Okay. So again, softwareenabledflash.org, and again, you'll start seeing more of us as we get out into the data center world, and then we're looking forward to seeing everybody again in London at SODACON next year. Hopefully we'll get over this COVID stuff and we'll have more people. So, okay, thank you very much.